everybody. Welcome to Stats Rescue 911. My name is Lynn, and in this tutorial, I'm going to show you how to analyze a significant interaction effect using tests of simple main effects. And this is for a mixed design. In other words, we've already conducted a two-way mixed ANOVA. We have found a significant effect, a significant interaction effect, and now we need to follow it up to find out exactly what the interaction effect is telling us. But before we begin, it would be very helpful if you knew the topics that are listed here on this page. So for example, between versus within subjects factor, how to do a two-way mixed ANOVA. I'm going to assume you've done that since we're following it up right now with more analyses. Main effects versus interaction effects, marginal means versus cell means, post-hoc tests, why error bars, and confidence intervals. If you don't know these topics, then please watch some of my other videos. I will have videos on all these topics if they're not up already, and that will get you ready for the two-way mixed ANOVA and the follow-up of tests of simple main effects. All right. Just a little bit of background information here so you'll be able to understand the data set that we're analyzing. My students administered a survey to other students, and this survey, among other things, was an attempt to determine whether or not people are more afraid of during the nighttime than they are during the daytime. So we have one factor here that was the time of day. So we have day fear, night fear, and that factor was within subjects because, of course, everybody who reported their fear during the day also reported their fear during the night. Then the second factor that we were interested in is what I've been calling the horror factor, and this is the preference that participants expressed in terms of their love or like or hate of horror movies. So it's again a between subjects factor. People either reported loving horror movies, liking horror movies, or hating horror movies. And then we simply recorded their fear scores on a Likert scale or a 1 to 10 scale. All right, so we went ahead, we analyzed the two-way mixed ANOVA. That was in another video. And we, in fact, did find a significant interaction effect. And I'm going to show you a picture of this interaction effect. Here we go. So fear scores, mean fear scores, are on the y-axis. And then you can see from the legend here, there were the people who said they loved horror movies, liked horror movies, or hated horror movies. And these are their mean fear scores during the day. And these are their mean fear scores during the night. Now, it appears as though that there may not be a difference between love, like, and hate in terms of their fear scores during the day. But over here, during the nighttime fear condition, it does appear that people who love horror movies or hate horror movies report more fear at nighttime relative to the group here who only likes horror movies. They reported less fear. Now, that indicates that there's an interaction effect because what's going on between the groups here during the day is very different than what's going on between the groups during the night. So we can't just, we could, I suppose, look at the plot and through a visual inspection tell people what's going on, but it would be far better for us to run additional analyses and, for example, find out which means are different from which during the day and which means are different from which during the night. All right, so that would be one set of post-hoc tests. One set of tests of simple main effects. All right, so we could do a test of simple main effects here to see where the differences are, and a separate test here, all right, to see where the differences are. Now, there's another way we could run post-hoc tests, Instead of doing that, we could compare, for example, just the love group and ask whether or not the love group changed from day to night. And then we could ask whether or not the fear scores changed for the like group. So those who like horror movies, did their fear scores change from day to night? And then similarly, we could compare the hate group. So we could look at their fear scores during the day and compare it to their fear scores during the night. Both sets of tests of simple main effects are fine. You could use one or the other. Sometimes people will do both just so they have a complete understanding of the interaction effect. Good news, we're going to do both. So this is the first one that I described. This would be referred to as the simple main effect of horror within day. That should probably say within time because there's day and night. So, but if we did compare this particular set of means, so if we compared the effect that horror preference is having during the day, that would be the simple main effect of horror within the daytime. All right. And to do this analysis, we have to ask ourselves if the people who are in each of these groups are the same or different. We've already established that there are different people. That is, you can't like horror movies, love horror movies, and hate horror movies as a general rule. You either love them, like them, or hate them. And so this between subjects factor has 3 different levels, 3 groups. So to analyze this data, we will need to conduct a one-way independent ANOVA. And then if that's significant, we're going to need to follow that up with post-hoc tests to see which means are different from which. Once we have finished this analysis, we will look at the simple main effect of horror within night. And this particular analysis is the same in that we need to run a one-way independent ANOVA, and that's because this horror factor is between subjects, and we have 3 means we want to compare. So this will be a one-way independent ANOVA. And then if that's significant, then we'll have to follow that up with post-hoc tests as well. And that will tell us which means are different from which. So that would be one set of post-hoc tests. The simple main effect of horror within day and the simple main effect of horror within night. But we could run these simple main effects as well. So this shows you the simple main effect of fear within each of the different horror groups. So this is actually the simple main effect of the time fear was assessed within each of the horror groups. So for example, we might want to compare this group here. This is the people who said they love horror movies. We'll compare their daytime fear scores to their nighttime fear scores. Similarly, we'll look at this group here, the group that likes horror movies. We'll compare their daytime fear scores to their nighttime fear scores. And then finally, we'll look at this group, which is the group that hates horror movies, and we'll compare their daytime fear scores to their nighttime fear scores. Now, each of these comparisons will be a dependent t-test, and the reason being is we're, first of all, comparing just 2 groups, 2 means, and the people in each of these groups are the same. It's a within subjects factor. So that means we'll need to run a dependent t-test. We'll end up running one here, and one here. All right. And just make a note, really this should say the simple main effect of time fear was assessed within each of the conditions. So within the love condition, the like condition, and the hate condition. All right, the next step would be to look at our data file. So we'll go over to SPSS where we've got all the data entered. Remember, we've already done the 2-way mixed ANOVA, and we found a significant interaction effect. So we're following up with tests of simple main effects. And the first one we're going to do is we're going to look at the simple main effect of horror within time. So that means that we are going to compare love, like, and hate for the day. And then we're going to compare love, like, and hate for the night. Now we can actually run both of these tests at the same time. We're going to go to Analyze. We're going to go to Compare Means, and then One-Way ANOVA. Now, the factor we're analyzing is going to be the horror groups. Oops, I've passed it here, horror. That's the factor, the independent variable. We want to compare love, like, and hate. And we're going to do that for both the day fear condition and the night fear condition. So we're going to end up getting 2 ANOVAs out of this analysis. We're going to want post-hoc tests in case we do get a significant one-way independent ANOVA. And I recommend LSD, Chaffee, and Tukey. Hit continue. We're going to go to options. We're going to ask for descriptive statistics and homogeneity of variance test. Then we're going to continue. And since this is so exciting, we're going to hold our breath and hit OK. All right. So the first box tells us a bunch of descriptive statistics for the love, like, and hate group during the day. So their daytime fear scores, their mean, standard deviation, standard error of the mean, the confidence interval, and whatnot. And we also have the same information for love, like, and hate groups during the nighttime fear, in the night condition. All right, scroll down. These are the results of our homogeneity of variance test. We're testing it with Levene's. And if you are using an older version of SPSS, you won't have all these options here. This is showing you the results of the Levene's test for the day fear condition. And it allows you to look at the test based on the mean, the median, etc. An older version of SPSS will only base it on the mean. So we're going to look at that. So we're going to look at the day fear condition, and we're going to want to know if we have homogeneity of variance here. So I can't see because of this. Let me click somewhere else to get rid of it. Here we go. Oh, look at that. We've got a significant Levene's test. That means we do have a violation. We don't have homogeneity of variance. Remember that the sig value in SPSS is the same thing as the p-value. It needs to be less than 0.05 to be significant, and it is. Normally, we would be happy, but not when we're testing an assumption. We never want a test for an assumption to be significant because it indicates a violation. So we've got a violation here for the daytime condition. Let's look at the nighttime condition. Again, we're going to go to based on mean. We're going to go over here, and lo and behold, we have a second violation. Now, when we have a violation, in this case, it's to the assumption of homogeneity of variance, we have a choice. I think probably the best choice for us at this point in time is to say that if we do find a significant ANOVA either during the day or night, we're going to make it a little more difficult for us to reject HO. That is, we're not going to reject HO and say that something is significant as long as the sig value is less than 0.05. We're going to lower that and say we're only going to reject HO and say something is significant if the sig value is less than, say, 0.03 or 0.01. All right, what we're trying to do here is make amends for the fact that we have a violation by making it more difficult for us to reject HO. All right, over here is the ANOVA. And remember, we have 2 ANOVAs. We have one on the love, like, and hate groups during the day, and we have one to compare love, like, and hate during the night. Let's look at the day one first. And we probably need to report degrees of freedom. We have 2 and 55 degrees of freedom. The within groups row, that becomes our error term. And this is the effect we're testing. So we have 2 and 55 degrees of freedom. Here's our F value. And we look over here and we have just found out that the one-way independent ANOVA on movie horror preference is significant for the daytime group. And if we look over here for the nighttime fear condition, again, we have 2 and 55 degrees of freedom. Here's our F value. It is also significant. That is the one-way independent ANOVA on horror movie preference for nighttime fear is significant. Now remember, we did have a violation to HOV, and we said that we were going to make it tougher on ourselves to reject HO. So let's say that we will only reject HO if the sig value is less than 0.01. Well, in both cases, the sig value is less than 0.01. So even though we have a violation, we can proceed and say that we have significant ANOVA. So these two tests of simple main effects are significant. We still need, though, to find out, well, which mean is different from which. So those are going to be revealed to us in the posthoc tests. Here are the posthoc tests for the day fear condition. We've got Tukey, Chaffee, LSD. And the nighttime fear condition, again, we have Tukey, Chaffee, and you can't see it, but LSDT is down here. We have to decide which posthoc test we're going to look at. And once you decide which one you're going to look at, because they can give different patterns of results. The Chaffee will find typically the fewest significant differences. LSDT will find the most significant differences, and Tukey will be in between. And what I tell students is look at the pattern of results for each of these tests and look for the one, if you have one that gives you support for your hypotheses, and that's the pattern you were looking for, then use that test. But, you know, typically if all three give you the pattern you're looking for, then I would report Chaffee. If, on the other hand, Chaffee does not give you that pattern of results, then look at Tukey. And if Tukey doesn't give you the pattern of results you're looking for, then look at LSDT. But keep in mind, once you choose a post hoc test for this daytime fear condition, you have to use the same post hoc test for the nighttime fear condition. Fair is fair. All right, for this demonstration, we're going to actually look at Tukey. And you may recall from a previous video that interpreting the effects of Tukey, once you understand that, you use the same procedure for interpreting Chaffee and LSDT. So if you can do it with Tukey, you can do it with the other two. Let me click over here, get rid of that box. Okay, so the first thing we're going to do with Tukey is we're going to ask ourselves whether or not the love and like groups are different from each other, significantly different from each other. So we go over here to the sig value and we learn that in fact they are. So there is a significant difference between love and like during the day in terms of their fear. We would look at the means to see which one is higher and which one is lower. And remember, whenever you're reporting significant differences, never just tell people that they are significantly different. You need to tell them which is higher, which is lower. All right, so now let's look at love and hate. And we go over here. So remember how to follow the rows. We go love, hate, follow the row. And we see it is not significantly different. These two means are statistically the same. The last comparison would be between like and hate. So if we compare these two means and look at the sig value, we see that these two means are also significantly different. So what have we learned from Tukey? Well, we have learned by looking at these sig values. Let me go back to the graph so that you can see. We have learned that even though initially we thought all of these means were the same, we've now learned that the people who love horror movies and the people who hate horror movies report significantly more fear during the day than people who simply like horror movies. All right, so this mean here and this mean is significantly higher than this one. Now we want to go look at the Tukey results for this ANOVA. So let's go back and we'll go to our results. Here is the nighttime fear. Here's Tukey. So we're going to look at love and like, and we're going to learn that these two are, again, significantly different from each other. Then we're going to look at love and hate. Speaking about hate, I hate how that box keeps popping up. Oh, now we lost our position here. Oh, well, let's do it again. So here's Tukey again, nighttime fear. We've already established that love and like are different. Love and hate are not different. All right, the 0.706 is above 0.05, so that's not a significant difference. And then the last comparison that we need to make is between like and hate. So if we compare these two, we learn that they are also significantly different from each other. All right, so we've got love and like, and we've got hate and like. If we go back to our graph, we can now see this, and this is perhaps a little more evident. We have learned, we've confirmed that the people who love horror movies and the people who hate horror movies report significantly more fear during the night compared to people who just like horror movies. Maybe I should just like horror movies. I'll experience less fear, maybe. All right. Now, remember that there's still another set of simple main effects we can conduct, and that set of simple main effects will compare the means 2 by 2. This time comparing day versus night fear for the love group, day versus night fear for the like group, and day versus night fear for the hate group. And each of those tests, because there's 2 means and there's the same people in each group, each of those means will necessitate a dependent t-test. So we go back to our SPSS file. Now we know we're going to have to run dependent t-tests on the hate group. In order to do that, you have to tell SPSS that you only want it to look at the people who hate horror movies. You want SPSS to ignore everybody who likes and loves them. So to do that, we go to Data, and then we go to Select Cases. And we go to this radio button, click here, and then click on the big if. And we say if horror, and then put an equal sign. If I can find my equal sign on this computer, we'll be in business. Horror equals 1. Now, what we've just told SPSS is that if anybody has a score of 1 for horror, those are the people who love horror movies. We want SPSS to only look at them. So select if horror equals 1 means only look at the people who love horror movies. Because I believe that's what we said 1 was. 1 equals love. So we're going to continue, and then we're going to hit OK. Let me go back to the data file and confirm that we selected just the love people, and we have. Everybody else is crossed off. We're only looking at people who love horror movies. Now we can run our dependent t-test. So we go to Analyze, and we go to Compare Means. We go to Paired Samples t-test. That's the same thing as the dependent t-test. And we tell SPSS what the pair is, and we want to compare day fear to night fear. And again, it's just going to be for the people who love horror movies. Hit OK, and here is our t-test. So we have the day fear score and the night fear score. Remember, this is just for the people who love horror movies. It would be a good idea at this point, if you double click next to t-test, you can write on the file and you can just put love horror. When you go back, you want to be able to recall which people you're analyzing here. It does tell you up here, it says horror equals 1, but it's so much easier just to see it if you type it in. All right, so we want to go to the box that's going to tell us if we've got, and would you look at that, this recording thing is in my way. Well, it doesn't matter because I can see the sig value. So I'm going to cheat here. Every time I try and minimize this, the recording stops. So this is comparing day versus night using the t-test. It is significant, as illustrated here. So we do have a significant difference between day and night. If we look at the graph, we've just learned, and I guess this isn't a surprise, but for the horror movie lovers, their fear scores do go up at night. Now let's find out about the people who like horror movies. So we're going to go back to SPSS. This time we're going to go to Data, select Cases, If, and then horror equals 2. This will select just the people, okay, who like horror movies, and we can confirm that. This time you'll notice that hate is crossed out and love is crossed out. Like is not. So we're only analyzing the people who like horror movies. We go to Analyze, Compare Means, Paired Samples, and it's already set up, so we just have to hit OK. I'm going to label this, double click here. These are the people who like horror. And let's see what we've learned. It is also significant. We scroll down here, we can see that the sig value is less than 0.05. So that means when we compare day and night for the people who like horror movies, we see a significant difference. Looking at the graph, we've now learned that if we compare like during the day to like at night, their scores go up as well. All right, so now we have one more comparison, and that's day versus night for the people who hate horror movies. Go back to your SPSS program. This time you go to Data, select Cases, and then that big if again. And this time select horror equals 3, type in 3. Continue. Okay. If we go back to the SPSS data set, we'll now see that the hate horror movie people, have been selected and everybody else is crossed off. So we're set to do our ANOVA. You go to Analyze, Compare Means, Paired Samples, t-test. It's already set up. Hit OK. Label it. Good idea. Hate horror. All right, and we can look at the results of this test, and no surprise, when we look at the paired samples t-test result, it is significant. So we have now learned, if we go back to our graph, that if we look at the people who hate horror movies, their fear scores go up significantly from day to night. So we have done all sorts of tests of simple main effects today. We have learned that through this last set of simple main effects, regardless of the group you're in, whether you're you love horror movies, like horror movies, or hate horror movies, everybody's fear scores increased significantly from day to night. All right. Even this group, you might not have thought that this was a significant increase, but it is. All right, we did that dependent t-test and it showed us that this is significantly different. So we have increased fear scores from day to night for all three groups. We've also learned, if we go back one, we learned through the first test of simple main effects that if you look at the people who hate horror movies and love horror movies, they are more fearful in the day compared to people who just like horror movies. Similarly, we have learned that compared to the people who just like horror movies, if you love horror movies or hate horror movies, you experience significantly more fear than the people who like horror movies. So I hope this has helped you. Of course, you'll be working with your own data set, but this essentially should help you regardless. You have to know which of your factors is between, which of your factors is within, and then run the appropriate test depending. Okay, so you could be doing a dependent t-test. You might be doing an independent t-test. You might run a one-way independent ANOVA or a one-way repeated ANOVA. And again, it just depends. You have to know, is the factor between or within? And then establish, am I comparing two means or three or more? If it's just two means, that's a t-test. If it's three or more, it's an ANOVA. All right, well, thank you for watching. I'll see you later.